You all to Physics Unveil. My name is Franklyn, and today we're talking about the application of Gauss law. All right, so we've discussed Gauss law in the other videos. Please go and check that out. So today we're talking about the application of Gauss law, and today we're talking about the electric field due to a charged spherical conductor. In this Physics Unveil, we try to summarize everything. All right, so now, for the electric field due to a charged spherical conductor, it's very simple. This time around, we're trying to check symmetry. Symmetry, in other words, means we're trying to say, okay, if a charge is in a spherical conductor or a charge as a sphere is on its own, what will be the electric flux or electric field? Now, remember that electric flux is equal to electric field times the area, right? All right. Now, when dealing with spherical, this word spherical is very important. In a question, when you see this word spherical, all right, the electric flux is equal to the total charge or the net charge over the permittivity of free space. Now, in a question where you see this spherical, you may see radius there. Right, you may see radius or whatever. Those radius are not important, right? Those radius are not important. So whenever you see in the question spherical, that word spherical is very important. And under Gauss law, finding electric flux or electric field, this is the electric flux for that question. All right. So let's solve a question and see what we mean by this. So let's go to question 1. So as you can see, this question says a positive point charge Q is equal to 3.0 microcoulomb is surrounded by a sphere with radius 0.20 meter centered on the charge. Find the electric flux through the sphere due to this charge. Now, remember the important word here, sphere, spherical, sphere. All right. Obviously, this is Gauss law, right? Because to find electric flux, this application of Gauss law. Now, write your solution. Okay, what is given? The net charge there. All right, so the charge Q is given as 3.0 microcoulomb, and that is equal to what? 3 times 10 to the power of negative 6 coulomb. Right, now by a sphere with radius 0.20 meter. The radius here is not really important because the flux due to a sphere is what? The net charge, right, divided by what? The permittivity of free space. So it just goes straight. Net charge is 3 times 10 to the power of negative 6, or divided by what? The value of permittivity of free space is 8.85 times 10 to the power of negative 12. So you can see it's very simple. So we have a positive point charge, which is this, right? Now, and it's surrounded by a sphere with radius this. It's not important. The radius is not important because whether you use the radius or you don't, you still get the same answer. So now, if you divide this 3 times 10, that should give us something like 3, 8, 9, 3.05 Newton meter square per coulomb. All right, so this is what the answer is. There you have it. So 3, or you can make it in standard form, and that will be 3.389. all right, that's okay. Is 1, 2, 3, 4, 5 times 10 to the power of 5 Newton meter squared per coulomb. And this is all for this question. So remember, any question with electric flux in it and it has this word sphere or any shape, as far as the point charge is at the center, all right, given with radius or with side, whatever, we make use of this formula. All right, let's see another question so I can understand what I'm talking about symmetry and about using this formula for electric flux. So another question. This question said a 60 microcoulomb charge is at the center of a cube of side 10 cm, what is the total flux through the cube, and what is the flux through one face of the cube? Now this question is a symmetrical question. Symmetrical meaning that there's a charge at the center of a cube. All right, since at the center of the cube it emits electric field symmetrically, equally, uniformly around the shape, around the cube. All right, so the solution for this problem is this. Because of symmetry, electric flux will be equals to the net charge over permittivity of free space. And if I remember very well, those in the Federal University of Technology of Owerri Futo, this question is in your textbook, all right, and the question there actually very wrong. So this is the correct solution for that question, all right? So now for solution, this is the solution, all right? We're using this called of symmetry. We're using this question called symmetry. So this will give us the charge is 60 micro is times 10 to the power of negative 6, all divided by the permittivity of free space is 8.85 times 10 to the power of negative 12. All right, and when you do your division, you should get something like 6.78 times 10 to the power what? 6 Newton meter square per coulomb. And it's as easy as that, right? So we have our charge, which is Q, equals to this over the epsilon naught, okay, permittivity of free space. And this is our answer. So this is how to do it. So any question on symmetry, a charge is at this center or at sphere. So when you see sphere, and when you see that a charge at the center of a particular shape, the volume of a shape, can be a cube, a cuboid, whatever the shape is, you make use of this formula, all right, start making use of radius. So let's go on to this number 2. What is the flux through one face of the cube? This is very, very simple, all right, because this is the total flux throughout the cube. So one face of the cube, remember that for one face of the cube you have to divide this by 6. When we divide that by 6, so for number 2, our flux now for just one face, since it's a cube, you divide this 6.78 times 10 to the power of 6 divided by 6. All right, because this is for the whole cube, for the 6 faces, and now this is what's for the first face. All right, so when you divide that, what will you have? 1.13 times 10 to the power of 6 Newton meter square per coulomb. And this is the answer for this question. It's as easy as that. Symmetry, spherical, make use of this formula. It is very, very highly important. I'm very sure you guys are writing and you guys are jotting. So this is all for the application of Gauss law for spherical, and what again? For symmetrical. All right, whenever a charge is at the center of a particular shape, all right, so you make use of this formula. And whenever I see sphere in a question, you still make use of this formula, because whether I use this formula or this to be the same thing, but this is preferable. So this is the end of this application of Gauss law. In the next video, we're talking about using surface charge density. All right, so don't forget to like and subscribe and share also. Right, so I'll tell you bye.